Well, it's a great pleasure to be able to welcome you and start with the first talk, what is mitochondrial disease? And I think everybody in this room would give a very different answer. So I'm sure we all have very strong views on what is mitochondrial disease. And, right, okay, well I'm not going to be able to show you at all, so that's it. So if you go on Google, of course, what you'll find is you'll find absolutely huge, overwhelming numbers of different articles on what is mitochondrial disease. And of course, you can look at them and it kind of rather hard to take it all in. I'm sure all of us feel a bit like this when we go on the internet, and if you go on social media, it may be even worse. So I would suggest that the good place to start is the Lilly website. And I think that we've also got our own websites for various different parts of the service with big input from Lilly, and I think they've done a terrific job on that. So actually I've gone backwards, that's great. So this is good, at least this is going to help for me. That's it. Okay, brilliant. But mitochondrial disease diagnoses, of course, are rare, which is of course why when, so for instance, the commonest type of childhood onset mitochondrial DNA depletion syndrome is 1 in 100,000 according to the statistics. So when you go and see your GP, how is your GP ever going to know anything about this? It's very, very tough for the general practitioners. So we suggest that you get in touch with your team. This is supposed to come on, because your team will be able to help you with a lot of the questions that your GP really isn't going to be in a position to answer. Mitochondrial diseases are actually considerably calmer than 1 in 100,000. The 1 in 300 is the number of people carrying a mitochondrial DNA mutation in the general population. So when you go out on the street, actually, probably there's someone out there who's got a mitochondrial disease, but most of those individuals won't even know they've got it. They'll perhaps get a bit of deafness when they get to my sort of age, and actually never discover that it was actually caused by a mitochondrial DNA problem. There are many different types of mitochondrial disease, and here's one of my favourite patients who actually didn't actually even come to medical attention until he was in his 70s. And you can see, because I'm a paediatrician, I like to test people's power by making them sit on the floor and get up. He actually managed it, which is pretty cool still. So they are very variable. And this youngster, who I'm going to call Fred Bloggs for the purposes of this presentation, actually came to medical attention with Lee's disease. I first knew about him when I was in the paediatric department in Oxford. I'd come in late at night to do my experiments, and I would meet his mum wandering around the corridors because he was on paediatric intensive care unit, and he was re-intubated, put back on a ventilator 5 times. When he went home, he had tubes coming out. We never thought that he was going to do well. And here he is. He's now 23. He actually lives independently, in supported accommodation, and he's got a girlfriend. And actually, that is someone who we thought was going to die when they were a child. And I think mitochondrial disease is very, very difficult for families because, of course, you hope for the best, but you have to plan for the worst, because who would think that a child with Lee's disease could end up like that? So, I think it is extremely variable. And I should say that I had one patient who had labours, so just a vision problem, loss of vision, and he had to pack in his university career because of that. But then he went back, and he was in the Edinburgh Festival doing a stand-up comedy. So people are amazing. One has to be impressed. So what kind of mitochondrial disease is it in your family? That makes a big difference to what we can say about it. And my kind of mitochondrial disease might be very different from the one of the family you're sitting next to and you're chatting to. So please bear that in mind before you go and make generalizations from one to another. I stole this picture from one of my graduate students who was giving a presentation. It shows mitochondria are very important in all sorts of different parts of the body. So if you've got a mitochondrial disease, it might just affect your eyes, might just affect your heart, but on the other hand, it could be more widespread. And I'd hate you to go away thinking, looking at all these different parts of the body that are in this picture and thinking, oh God, I'm going to get a liver disease and a kidney disease, etc. Actually, different disorders are different, but mitochondria are very important for every part of the body. Now, what we don't understand is why one particular mitochondrial disease can affect one person in one way and another person in another way. And actually, even the same disease can be quite different for different people. And so, even within a family, you can get really quite substantial differences. So, and we don't understand why. A lot of us are working on trying to understand that. But what about if you've got no diagnosis at all? Well, obviously, that's a worry. But be reassured, we are getting better at making diagnoses. So my colleague Anu Sumalainen from Finland has developed a new screening test, which is helpful in a proportion. It's another way, but they're developing more screening tests with a view to make it easier to say this patient's got a mitochondrial disease, we don't know what it is, and this one probably hasn't. So I think that's a big advance. And later this morning, you're going to hear presentations from the next generation sequencing team. I couldn't find a picture of Cherry, I'm afraid, but I think she's well hidden on the internet, actually, if you look for her. So they'll be telling you about the new next generation sequencing and how that's going to help us make more diagnoses. But how do we treat mitochondrial disease? Well, of course, very much we don't have any big cures. We can't make everybody better. We're getting better at small things, and Lily has been funding some new initiatives of treatments, which are very exciting. Mostly we focus on what it is that's the problem. We treat that. So if you've got diabetes, then we treat the diabetes. If there's a heart problem, we send you to the cardiologist, and they check it. They give you heart drugs and things. So there aren't that many things that are specific for mitochondrial disease. What we think really makes a big difference to people's survival is having information, and that's why we issue people with emergency information sheets. And this is actually just the Oxford one. All the different centres have their own types, and what we do is we have your name and stuff on and contact details on one side, and on the other side we have a list of things to keep the doctors on their toes. Now, so when you see your emergency sheet, you think, oh my God, I'm going to get all these, am I? Well, the answer is you're not. The idea is that you have your emergency sheet so that when you go to that on-call doctor who's completely harassed and can't give half an hour to go on the internet to find out about what your disease is, that they can go back and have a look down on a checklist to remind them. So don't, when you read your emergency, don't think you're going to get all those diseases. It's to keep the doctors on their toes. And we think that this makes a substantial difference. I think most of the other doctors in the room would agree with that. How can we, but the main thing is keep in touch with your team. If you haven't got an emergency sheet like that, then please ask us, and we'll get you one issued. Ask your team. Enroll in the cohort, because that will be very helpful for developing treatments. And because I got very excited by being able to do this, and I have to put my team up again. So, it's a bit of a recurring theme once you learn. Okay, so we've all heard about 3-parent babies and mitochondrial replacement therapy, and I think that's going to be a theme of the talks later on. And of course, it is just starting in the UK, so that's pretty amazing. Don't forget, this is not a treatment; it's a way of preventing mitochondrial disease in the next generation. And what actually happens is, again, you'll be hearing in the talks later on, so the nucleus gets taken out of either the egg or the fertilized embryo, and the nucleus is removed, and then mitochondria from an unaffected oocyte or embryo from the same stage are put together, and you end up with a 3-parent baby. It's said to be like changing a laptop battery, and of course that's true how it is, in the sense that it's the energy supply that's being switched over. But actually, it's really it's really not as simple as that. We've also heard that people have been saying that it could be made available to women in the next 3 years, really for many, many years. So I think there's been a lot of overselling of this, because actually, although it's exciting basic science, It's not relevant for most families, because most families have got recessive disease where it's not going to be relevant, and there are alternatives for all the other sorts of mitochondrial disease. So it's exciting, and it's starting, and it may be fantastically effective over the next few years. But actually, it's not as easy as changing a laptop battery. So mitochondria, they make energy, that's very exciting. And how does it actually work? So if I'm going to see if I can get this to do its bit, I'm not sure I can. Let's see. Yeah. So even though they look like little sausages in cells, in fact, they're a dynamic network. And you see here the red are the mitochondria dancing about, and here's the nucleus, the controlling centre of the cell. And so mitochondria are able to move to the part of the cell where they're needed. And if this was a picture of a nerve cell, a neuron, you'd see the mitochondria zooming along the axon of the nerve cell to the terminals where they're needed, and then coming back to the cell body to be refurbished. And so they are, and the whole field of studying mitochondrial dynamics or movements is quite new and very exciting. So how does it work? Well, as you know, on the surface of the mitochondrion, there's this thing called the respiratory chain. When people say you've done your respiratory chain function, that's what they're referring to. This is like a conveyor belt. It's a production line for energy. And so if you can kind of imagine a row of bricks that you've put up, and you tip the first one over and it knocks the next one, what happens is the activation energy hands on from one complex along the chain. And as it happens, while that's happening, then these things called protons get pushed out of the mitochondrion. So I'll just show you that in a nice little video. There you are. So here they are. Here's the charge being pushed out as the production line for energy goes along, and as the energy goes from one complex to another. So the charge is going up to the outside of the mitochondrion. And then what happens is that the complex 5 of the respiratory chain is kind of like a water wheel. What happens is the charge then comes back in to the mitochondria, and as it does, what happens is the rotor of the complex 5 is pushed round like a water wheel, and as it does, its paddles go in and out like this, squeezing together this thing called phosphate and ADP to make ATP, which is the energy currency. So you can kind of see how the respiratory chains, this conveyor belt making energy, pushes the charge outside, and then the charge is used as a stream for squeezing together the right chemicals for making the energy currency. And that's all been found out in the last 20 years, and I think it's absolutely fantastic that we can actually think of it in those terms. So mitochondria are very complicated, they are difficult bits of machinery, and actually how we inherit them is also somewhat difficult. So there are 2 sets of instructions for mitochondria, and it's the sets of instructions, the DNA, that of course tells you which type of mitochondrial disease you've got. And it's kind of like when you get your new camera, there are 2 sets of instructions that you get. You get, well, in my day, the handbook, or the sort of disc with all the instructions on. That's kind of the cell nucleus with a lot of the techie stuff, the really important detailed information. But actually, when you get your new camera, the bit you really want is that card that gives you the day-to-day instructions to tell you how to use the camera, and that's like the mitochondrial DNA, the energy for the mitochondrial DNA, which gives you, so you have 2 sets of instructions that you need for your camera. And so actually, when you actually come to it, you need to think about whether the DNA change that you've got is in the nuclear DNA or in the mitochondrial DNA. Was that a card telling me I've overrun?
No.
Sorry?
You've got 1 minute.
I've got 1 minute. Okay, brilliant, excellent. Well, in that case, I shall flip through the next little bit. That's great. We go through all this. That's it. So really, just to say that it's fabulous that Lily is funding research. Research is, to get from research to treatment is a real uphill struggle. So at the moment, my group is doing basic research, and what we hope is that we'll find something which is going to help us go through the valley of death and start doing clinical trials. But the problem is, as you go on, what you'll find is it's more and more expensive for making stuff, and to get a cure, you guys, with raising the funding, have been absolutely fantastic, because it's a real major thing, and we're talking about 3 to 6 years on the first stage, 6 to 7 years and then for the last years, a couple of years. So basically talking about over a decade to go from basic research to actually getting a drug. And actually that's something we need to be realistic about, because I don't want people raising their false hopes. So this is us for my team, and thank you all very much. We need volunteers. Thank you.